we'll do one little lecturette and demonstration, and then I'll let you do the homework. All right, so here we go. Projectile motion, stationary launcher practice problem. So this is something that we're going to be used to doing because something that we learned from early when we were shooting from the ground to ground, right? When we shoot something from ground to ground, we were able to calculate the range and the height and time and all that good stuff, all right? So number one, a pineapple is launched with an initial velocity of 55 meters per second at an angle of 45 degrees on a long flat range. Now, when they say flat range, this means my delta y is equal to 0, or y initial is equal to y final, which is equal to 0 meters. Okay, that's what that flat range means. Okay? So, whenever you see something like this, before you even start the problem, I would recommend that you work this V naught out into its x and y components. Okay? So, first thing is draw separately away from the diagram and then draw out this V naught. Okay? And with this V naught drawn out, you could break that V naught up into its VIX, okay, and your VIY. Okay. And this angle, the launch angle, theta naught, happens to be 45 degrees. So just by knowing that this is 45, your x and y components should be the same, right? So your VIX is equal to simply V naught times cosine of theta naught. Therefore, when you plug in the values, your VIX is equal to 55 times cosine of 45 degrees. So when you calculate your VIX comes out to 38.9 meters per second. Okay, so this is good to know. And then your VIY, obviously because it's 45, V naught sine theta naught, or 55 times sine of 45, should be exactly the same value. So 38.9 meters per second. If you don't believe me, check it out yourself. Okay? So once this is calculated, now you can start solving problems. So for part A, what is the maximum height achieved by the pineapple? So at maximum height, when the pineapple is way up here at maximum height, they want to know what this y final, y max is. Okay, that's what they want you to figure out. But we all know V final at y max is equal to 0, right, when it reaches the maximum height. Therefore, we know our initial position is 0, right, and then we can find out how high that thing goes. So for part A, let's write down everything we know in the y direction. So for example, we know VIY, we just know is 38.9 meters per second. We also know VFY max, which is equal to 0 meters per second. We also know A sub y, which is equal to negative 9.8 meters per second squared. We know our y initial, which is 0 meters. And we are looking for y final at y max, right? That's what we are looking for. And therefore, it looks like we have all this stuff except for time, and when we don't have time, then we have to use equation number 3. And equation number 3 states VFY max, right, square is equal to VIY squared plus 2a sub y times y final minus y initial, right? this y final is the y final max. This y initial is 0. So here, VFY max, we know it's 0. Square that, still get 0. VIY is 38.9. Square that, get a big number. Plus 2 times negative 9.8 times y final is what we're looking for, minus 0. Therefore, 0 is equal to, square this and you get something like 1513.2 minus 19.6 y final plus 0. So bring this to the other side, you get 19.6 y final is equal to 1513.2. So my y final, y max, comes out to 77.2 meters as your answer. Alright, now for part B. Part B asks, what's the total time of flight before landing? So for part B, we're looking for T total, right? This is what we're looking for. So for total time, this is our initial, and now this is our final position, right? Our y final is at the other end when it's back to 0 meters. So let's write down everything we know. We're looking for total time. My y initial is 0. My y final is 0. My VIY is equal to, we calculated to be 38.9 meters per second. We also know a sub y is equal to negative 9.8 meters per second squared, right? Well, it looks like we have all the ingredients for equation number 2. And equation number 2 states y final is equal to y initial plus VIYT total plus 1/2 AYT total squared. Alright? Now if we plug in all the values, y final, 0, y initial, 0, plus 38.9 T total, plus 1/2 times negative 9.8 times T total squared. Therefore, 0 now is equal to, I can factor out a T total from both of these terms, right? Times 38.9 minus 4.9 T total, right? So either my T total is 0, then this doesn't matter what this parentheses is, 0 times anything is going to be 0, which would satisfy my equation. Or anything inside this parentheses works out to be 0. It doesn't matter what T total is, and you still come out to be 0 because you're multiplying T total by 0. So my T total is equal to either 0 or this right here, 38.9 over 4.9, right? And that comes out to, I think, 7.94 seconds as my T total. So I would accept that. All right, and that makes, these two answers make perfect sense, because when T is 0, my y initial is 0, and when my T is 7.94 seconds later, my y final is 0. So it works out for both. And for part C, how far away the pineapple strikes the ground. So for part C, they want to know what your delta x is, the range, right? And this is the range right here, right? That's the delta x, okay? So my VIX is equal to, we calculated to be 38.9 meters per second for my VIX, right? So that was easy. And we know T total now, because we just calculated that to be 7.94 seconds, and we know A sub x is 0, always. Therefore, if we use equation number 2 again for the horizontal, my delta x is equal to VIX times t total plus, 1/2 a sub x t squared, but a is 0, so the whole term drops out. Therefore, my delta x now is equal to VIX, which is 38.9, right, times t total of 7.94 seconds. So my delta x is equal to, it comes out to be 308.9 meters as your delta x. That's the range. Okay? Now for part D. Is the pineapple moving upward or downward at the 5-second mark? Well, just by using logic, if it takes about 8 seconds to go from here to here, the maximum height should be around where, or what time? If it takes 8 seconds to go from here to here, what should the maximum height time should be? Around 4, right? So at 5 seconds, what would it be? On the way up or on the way down? Definitely on the way down. So you could work that out logically, saying, oh, it's probably on the way down, right? So we can safely estimate, okay, it's going to be somewhere around here, let's say, and it's going to be going this way when t is equal to 5 seconds, okay? So when t is equal to 5 seconds, most likely it's going to be past the halfway point on flat land. Therefore, this projectile will have VFX at 5 seconds, right? This VFX, we already know what that is. And this will also have VFY. We need to calculate this to see if this comes out to be negative or not, right? So let's do that. So for part D, let's write down everything we know. So we know t is equal to 5 seconds, and that's given to us, right? We know VIY is 38.9 meters per second. We know a sub y is equal to negative 9.8 meters per second squared. Let's find out what the VFY is at 5 seconds. We can use equation number 1, which is VFY is equal to VIY plus a sub y times time. And this time is 5 seconds. Therefore, my VFY is equal to VIY, which is 38.9 minus 9.8 times 5. So if you work it out, my VFY comes out to 38.9 minus 49. So my VFY comes out to negative 10.1 meters per second as my, and look at that, because it comes out to be negative velocity, it must be going down, right? So going down because VFY is negative, right, at t is equal to 5 seconds. So, boom, there you go. Was that easy enough? All right. And then for part E, they're asking us to the velocity. Now they're looking for velocity, which means it better have magnitude and direction, or it could be Cartesian form, at 5 seconds after launch. So they want the velocity of this. This is the VF they're looking for right here, right? In magnitude and direction form, which means that they want in polar form. We already know what VFX is. At any point along this trajectory, my VFX is always going to be same as my VIX, because my acceleration in the x direction is always 0. Therefore, my VFX at any point along here will be always 38.9 meters per second. So that's easy. we just calculated my VFY at 5 seconds, and that happens to be negative 10.1 meters per second. We just calculated that. So for part E, we could say, wow, my final velocity when t is equal to 5 seconds, right, is equal to simply 38.9 x hat minus 10.1 y hat meters per second. So that's Cartesian form. Now they want you to figure out the magnitude and direction form, so all you have to do is just use the Pythagorean theorem to figure out the magnitude first. So the magnitude of the final velocity at 5 seconds is equal to square root of, right, simply 38.9 squared plus, right, 10.1 squared, and if you work that out, I think that comes out to 40.19 or 40.2 meters per second. So that was easy. Now to calculate this angle theta final at 5 seconds, this angle theta. So this angle theta final is equal to simply tan inverse of, right, VFY, right, over VFX. Therefore, this is same as tan inverse of, right, negative 10.1 over 38.9 as your angle theta. So your theta final at 5 seconds comes out to negative 14.55 degrees. So we have that. Therefore, now to do final velocity in polar form at 5 seconds is equal to simply 40.2 meters per second, comma, theta final is equal to negative 14.55 degrees as your final answer. Alright, did you guys get that? Now don't forget, this is going to be in your quiz Friday, right? So you best know how to do this. And this page as well, right? And this page as well. So let's take a look at this page. Alright, so this is very, very similar to the example problem I did it with you, right? So this is lab plus the quiz, so you best know how to do this. Alright, so a projectile is launched from the edge of a cliff 115 meters above ground. So this right here tells us that this is my y initial, where it starts, right? And the initial speed of 65 meters per second. So this looks like my v naught, my launch velocity or initial velocity at angle of 35 degrees. That's my theta naught above the horizontal. So right there in one sentence gives us a lot of information. All right, so most likely this cannonball is going to go, you know, parabolically as such, okay, and then land somewhere on the ground here, okay. So again, before I even start solving for anything, my first thing I should do is find the VIX and VIY. So draw out your V naught, right? So draw out your V naught. Right? So here is your V naught, which happens to be 65 meters per second, right? And then you need to calculate your VIX and your VIY, right? So this is your VIY, and then this is your VIX, right? And then this is your angle theta naught, which is 35 degrees. So always start here. Okay? Don't forget that. So, let's calculate your VIX and VIY. So, what's your VIX? Your VIX is equal to V naught cosine theta, which is 65 times cosine of 35 degrees. And if you work that out, your VIX is equal to, I get something like 53.2 meters per second. Okay, so that's good to know. And then your VIY, so VIY is equal to V naught sine theta, so 65 times sine of 35 degrees. And if you work that out, your VIY comes out to 37.3 meters per second. So you need to find these out first before you do anything else. Okay, so please make sure you start here. Now I can say, okay, my Y initial happens to be 115 meters. My Y final is equal to 0 meters. Okay. And then part A says the flight time for the projectile. They want to know what the total time it takes to go from here to all the way down to here. They want T total, right? So for part A, right, your Y, let's write down everything we know. Your Y initial is equal to 115 meters. Your Y final is equal to 0 meters. Your VIY is equal to 37.3 meters per second. Your A sub Y is equal to negative 9.8 meters per second squared. And I'm looking for the total time, T total. This looks like equation number 2. So equation number 2 states Y final is equal to Y initial plus VIY T total plus 1/2 times T total squared. Again, 0 is equal to 115, so 0 is equal to 115 meters plus VIY is 37.3 T total plus 1/2 times, I forgot the A sub Y, sorry, negative 9.8 times T total squared. Whew. So I like to write this down in descending order. So 0 is equal to, here's negative 4.9 T total squared plus 37.3 T total plus 115. So you could tell this is a quadratic equation. Here's my A, here's my B, here's my C. So if you use your quadratic formula that you programmed into your calculator, you should get 2 answers, one being negative, other being positive. The positive answer came out to be 9.97 seconds as your T total. Okay? Then for equation, or for second, part B is flight time of the projectile. No, that's A. How far away would the projectile strike the ground? Well, we're looking for my delta X right here then, right? So this is the delta X that I'm looking for in part B. So delta X is what we're looking for here. And since we already know my VIX, which is 53.2 meters per second, I know my T total. My T total is equal to now 9.97 seconds. A sub X is 0. Therefore, if I use equation 2 in the x direction, my delta x is equal to VIXT total plus 1/2 a sub xt squared, but this a sub x is 0, so the whole term just drops out to 0. Therefore, my delta x is equal to VIX, which is 53.2 times t total, which is 9.97 seconds. So my delta x comes out to 530.4 meters as my delta x. Alright. And then for part C, maximum height above the ground. Alright, well, that's not that hard, because we already know exactly how to do this one. They want to know how high this thing's going to go from the ground, and what's the maximum of that, right? So this is y final, y max, right? That's what they want to know, right? But we already know my VFY max is 0, because at highest point, the velocity in the y direction is 0. Okay, so we know these two already. So let's write down everything we know for part C. So for part C, we know my VF at y max is equal to 0. So it stops instantaneously at the maximum height. I already know my VIY is equal to 37.3 meters per second. I know a sub y is equal to negative 9.8 meters per second squared. And I know my y initial is equal to 115 meters. And I am looking for my y final at y max. So now here's my initial and here's my final position, right? Instead of my initial and my final here, it's now initial and final here. So this looks like I have no time here. So it looks like equation 3 would be a good equation to use, which is VFY max squared is equal to VIY squared plus 2a sub y times y final minus y initial, right? Well, here, get 0 square that, you should still get 0. Here, you get 37.3 square that, get a big number, plus 2 times negative 9.8 times your y final is what you're looking for, minus 115. So, 0 squared, 0. 37.3 squared, I think is 1391.29. Right? Then minus 19.6 times y final is negative 19.6 y final. And then negative 19.6 times negative 115 gives you positive, right, 2,254. So if I bring this negative 19.6 y final to the other side of the equal sign, it becomes positive, right? And that is equal to, this plus that gives you a big number, which is 3,645.29. So my y final at y max comes out to 186.0 meters as my. So this is how high above the ground that cannonball is going to reach. Alright. Now for part D. It looks like they want to know what the velocity, right? What the velocity, magnitude and direction wise, when it hits the ground, like ground right here, strikes the ground. So if this thing's going to be traveling like this, that's my V final. Right? And since it is going to be traveling at an angle, we know that this can be broken up into its VFX and VFY, right? And this angle here is my theta final. But we already know what this VFX is, don't we? What is it? How'd you get that? Yeah, because it's always going to stay at VIX. No matter what time it is, my x velocity will always remain same as my VIX, which is 53.2 meters per second. Good. However, my VFY, it will change depending on what time it is. So we better find this VFY using my total time, which is 9.97 seconds. So let's do part D now. Part D. So we already know my VFX. So my VFX is equal to VIX, which is equal to 53.2 meters per second. Good. You know that already. So that's easy. That's done. However, my VFY is equal to VIY plus A sub y times T total, because that's the time that I'm looking for. I'm looking for the velocity in y at that time. So my VFY is equal to, initial velocity in y is 37.3, so 37.3, right, minus 9.8 times 9.97 seconds. So if you work that out, okay, you're going to get my VFY is equal to 37.3 minus 97.7. So my VFY is equal to negative 60.4 meters per second. So we know now these two final velocities in x and final velocity in y. So my VF is equal to, right, 53.2 x hat, right, minus 60.4 y hat meters per second. But that's Cartesian form, right? They want this in polar form. So we need to find the magnitude of that final velocity, which is square root of, right, 53.2 squared plus 60.4 squared. And if you work that out using your calculator, your final magnitude velocity comes out to 80.5 meters per second as your magnitude of your final velocity. Now they want you to find the angle, the direction, which is tan inverse of VFY over VFX, which is negative 60.4 divided by 53.2. So my final angle theta comes out to negative 48.6 degrees. So now I have both ingredients to write my final velocity in a polar form as 80.5 meters per second, comma, theta final is equal to negative 48.6 degrees. Boom. All right. Yes?
Would the final velocity be negative because it's traveling downward?
No, because this is the magnitude. And magnitude cannot be negative because we took the square of each and square root of it. Therefore, it's always going to stay positive because it represents the numerical value of that velocity. Okay? Any other questions? All right. So, today, that was your homework. So, today, I'm going to go over, so I'm going to ask you to do this and this for your homework today for pages 15 and 16. And I'm going to ask you to do in class tomorrow pages 9, 10, and 13 in class. All right. However, let's take a look at this. Page 14. This is just the concept, all right? So projectile motion, moving launcher, right? The basics. So if you were, working in Peace Corps and you want package dropped to a certain village, like a medical supply, right? They don't have a landing strip, so they would do a flyby and they would drop this package, right, from an airplane. And when it starts to fall, when they do a drop, literally they would just open the hatch and they'll just let it go, release it and drop it. Okay? Well, what happens when that happens? The package will stay right underneath the plane. It'll follow the plane, right? Straight, and then it'll fall right underneath the plane if there's no air resistance. If it's done in vacuum. Okay? So it basically will stay right under the airplane, right? That's why when they drop the big bomb, as soon as they release it, they had to like turn away, or else they'll be right under the blast. You know? So the important thing to recognize is whatever the initial velocity that airplane had horizontally, the V0, that would remain with the package horizontally as your Vx, right? That Vx is exact same speed as your airplane's original speed V0. Okay? So even here, this Vx will still remain the same, right? So Vx will always be same as your V0, which is same as the airplane speed. However, for y, it'll get bigger and bigger. All right, so I'll stop there.